Hello, friends. My name is Satya. Welcome to this vlog. As part of this vlog, we'll discuss about a protocol which is used to avoid loops in the layer 2 networks, right? So, the protocol that I'll be discussing today is spanning tree protocol. So, what exactly is a spanning tree protocol and why it is used? As I specified, spanning tree protocol is used to avoid the loops that is created in the layer 2 networks. Now, first of all, we want to understand like who wants to create a loop in the real world scenarios, right? Nobody wants a loop, right? So they want to make sure that the ports are not connected back to back. And for example, let's assume three switches: A, B, and C, right? So you connect A to B, B to C, right? And then A is connected to a upper link and C is connected to the down link, right? So we don't connect A to C. Then usually it will be a loop. Loop will not be formed. So, for example, by mistake or due to certain network design, we connect C to A also. Then there will be a loop, right? A packet will keep on traversing within ABC, ABC, ABC like that, and it will create a broadcast tone. So, to avoid that, we use a spanning tree protocol. As part of spanning tree protocol, each switch will each switch enabled with STP or spanning tree protocol sends a BPDU packet, right? A BPDU message. This BPDU message contains the bridge IDs, right? The lowest bridge ID port will be lowest bridge ID switch will be designated as a root bridge, right? So rest of the things will be acting as always want to send the packet through the root bridge. So for example, A as bridge ID as 1, B as bridge ID as 2, C as bridge ID as 3. So you have A, B, C. A as 1, B as 2, and C as 3. So when they establish the spanning tree protocol BPDU exchange BPDUs, they'll come to know that A is the switch with the lowest bridge ID, so they will select that as root bridge. So all the packets will traverse through the A port only, right? So for example, depending upon so in the layer 2 network, so MAC addresses will be used to transfer the packets. So depending upon the MAC address table, your packets will be transmitted. So the port that is facing all the ports as part of the root bridge, that is switch A, right, will be called as root ports. Then on switch B, where you connect to the root switch, that will be called as the port connected to the root switch is called as root port. Rest of the ports are called as designated port. Okay, in the similar way in C, the port that is connected to the switch A, which is the root bridge, will be called as root port. Rest of the ports will be blocked because A connects to B, B connects to C, right? So A is a root port, so all the ports connected to A, that is this port and this port, will be called as designated ports, and they are pointing to the network segment, that is outside the switches. Outside this network segment, there is another segment, network segment, so we can forward the packets or bridge the packets, right? So which are the switches which are remaining where the port has to be blocked is in switch B and switch C. So the port connecting to the root switch, that is A on B, will be called as root port. C also in a similar way, it is connecting, this port is called as root port on the C. So either on the B or C, this whatever link that is connecting B and C will be, one of the ports will be blocked so that communication does not happen and the loop does not created. So this is how a STP protocol control plane communication and the actual data communication happens. Let's take an example. We want to send a packet from B to C, right? So how will it go? If the STP is enabled, it will go through from B to A to C. So there is extra hop. Otherwise, we could have directly gone to C. We blocked it because it will create a loop. For example, if A wants to send to B, so it will also send through this link and it will also send through the C also. So it creates a loop, right? So what is the problem of having STP? The problem of STP, just now I discussed, if the packet wants to be sent from B to C, it will go through B, A, C. So there is an extra hop, so there is an extra delay or an extra hop in the layer 2 network that it has to transfer through. So that is an inefficient way of doing the transfer. But if you connect B and C in this way, a triangle way, then it creates a loop. So STP is used to solve the loops, but it is little inefficient in transferring the packet. So especially it puts a delay. It adds more hops to the transferring of the packet. To solve that, you have RSTP and MSTP, which I'll discuss in the next vlog. Okay. To summarize, friends, STP stands for Spanning Tree Protocol, which is used to avoid loops in the network. The topology that we considered was a triangle, right? So the top one is A, left one is B, and the right one is C, right? So whichever switch has the lowest bridge ID will be considered as the root switch or root bridge, right? So here A was 1 bridge ID, B was 2 and C was 3. So the lowest bridge ID is A. So A will be the root. All the ports on B and C pointing to the root switch is called as root ports, and all the ports on the root switch is called as designated port. Designated port means a port connecting to the network segment, and a root port is a port connecting to the root switch, and the blocked port is actually blocked, right? So I also explained how the data communication happens, and the only inefficient way of using the only inefficiency is extra hop will be used in 3 switch topology in the triangle form. If you want to send a packet from B to C, on either B or C, the port, one of the ports will be blocked, or either on B or C, so it will go through BAC and CAB, right? If packet wants to go from B to C or C to B, so it's an extra hop that will be required, which makes the communication in a delayed way, right? So friends, this is what I want to discuss. If you have any questions, do put a comment. I will answer to them. Okay, thank you. Bye.